Good morning. We are going to start where we finished yesterday. Somebody had asked me to do another tangent. So I'm going to take a look at A, and I'm just going to replace cosine here with tangent. And that's only because somebody asked me to do another tangent example. So when you're given the angles and you're asked to find the sum and difference, then the way that you're going to do that is find all of the missing pieces for alpha and beta. In this particular example, I don't care what the angle is. I want those ratios. I don't care what the angle is. I don't care what alpha is. I don't care what beta is. I want to know what the ratios are. So I know that if I have the tangent of alpha plus beta, this is equal to the tangent of alpha plus the tangent of beta, 1 minus the tangent alpha, tangent beta. So I need to get those ratios for alpha and those ratios for beta. The first thing I'm going to do is go off to the side and I'm going to deal with my alpha. And the way I deal with my alpha is I pull off the information that I have and find the information I am missing to get that ratio for tangent. So I know I'm in quadrant number 2 for alpha. So over here, I'm going to work with alpha first. I'm doing in what color you all want alpha in? Yellow, purple. Is yellow going to show up very well? Does it show up okay? I get yeses and nos, so I'm going to do it in red. Sorry, it's going to be in red. So my alpha, I'm going to work with my alpha over here, and I know I'm in quadrant number 2 for alpha. If I'm in quadrant number 2 for alpha, that means if I'm chasing tangent, do I expect tangent to be a positive answer or a negative answer? Negative. So I'm expecting tangent to have a negative answer. So I use the information that I know. I know the cosine, or wait, they're giving me the sine, I think. The sine, yep, sine. So they're telling me the sine of alpha is 3 over 5. Which pieces in terms of x, y, r did they give us? Y and r. So y is 3, r is 5. I am chasing x, plus and minus. It's going to be r squared minus y squared. Because I'm in quadrant 2, am I going to take the plus or the minus? I'm going to take the minus. So I'm going to put a minus there. So I need the x value because my tangent is defined as my y value over my x value. So that's why I'm chasing my x value. I'm looking for that ratio. So x is equal to the negative square root of 25 minus 9. 25 minus 9 is 16. Square root of 16 is 4. So x is equal to negative 4. My tangent then is going to be 3 over negative 4. And that tells me when I come over here, I can now put wherever I see the tangent of alpha, I can replace those values with negative 3 over 4. So this is equal to negative 3 over 4 plus, and then minus 1, negative 3 over 4. Now I still need to get the ratios for beta. So I'm going to come over to the other side and do beta. I'm going to use blue. So I'm going to do beta now. They tell me that beta is in quadrant 1. So what do I expect my tangent value to be, negative or positive? So I'm expecting a positive for tangent. They're giving me the sine of beta, which is 5 over 13. What do I have, x, y, r? Which ones do I have? I have y and r. Y is 5, r is 13. I am chasing x. Should be plus and minus, but I'm in quadrant 1, so which one do I take? The plus. So it's going to be 13 squared minus 5 squared, and this is a 12. 3, 12, 3, 13, 12 triangle. So 13 squared is 169 minus 25, which is 144, so it's a 12. So now I just have to find the tangent of that, which is 5 over 12. So I go back over here, and I'm going to replace the tangent of beta with 5 over 12. How was that so far? You doing okay? So excited about it? Okay. So now, need to move all this off. Now I'm going to finish this up and clean it up. As I look through my fraction within a fraction, my complex fraction, what is my lowest common denominator?
12.
Not quite 12. 4 times 12. And the reason that is because of this. This 4 times 12 is where my denominator, my lowest common denominator is. Normally it would have been 12 if that wouldn't have been a multiplication, but because it is a multiplication, it's going to be 4 times 12. So I'm going to multiply everything by 4 times 12. To clear my fractions. My first fraction here, my 4's are going to cancel, leaving me negative 3 times 12. And then plus, my 12's are going to cancel, 5 times 4. Here I'm going to get 4 times 12, nothing's going to cancel. But in this second grouping, the 4 and 12 both cancel. So it's a minus negative 3 times 5. Yeah, I'm feeling you. The yawning and the, I'm feeling you. Okay, in the numerator, I'm going to get negative 3 times 12, so that's negative 36. And then 5 times 4, which is 20. 4 times 8, which is 48. And then it's a plus because it's a minus minus, so it's plus and 15. What do we get in the numerator? Negative 16. What do we get in the denominator? Bless you. 63? Is that as good as it gets? Can I reduce any more? Nope. So there is the answer in all its loveliness. How was that? Not too bad. Just a lot of ratios to chase and find. And notice when I do this, I do the alpha in one area and the beta in the other because that's what I need. I need alpha and beta, and I just want to separate the two. How you set it up on your homework or how you set it up on the test is up to you. But for me, I have a tendency to get lost in my own work, so I go left and I go right. You all do what you need to do, though. Okay, so we're going to move on to the cofunction. So here's some more. So if you haven't already done so, now is the time to make sure you are carrying with you every single day that formula sheet so that you don't have to keep writing these down. Because every single one of these is on that formula sheet. You do what you want, though. So these are cofunctions, and we're going to really see what this means when we start doing the graphing after this test. So after this test, or I think maybe we do the graphing. I think we graph in this one. So when we do the graphing, you're really going to see what cofunction means. So if we take a look at our first one, the cosine of pi minus theta is equal to sine theta. This is a shift. So if we look at the way that we remember our transformations of graphs, which we're going to get to in here, it was if we have some function f of x, then g of x is equal to a f of b x minus c plus d. Do you all remember the transformations of graphs? Because that stuff's going to haunt you until you finish math. So if you weren't skilled at transformations of graphs, here's an opportunity for you to become skilled at the transformations of graphs, because we're going to see it again and again and again. My calc students are seeing it. You all will see it. It is going on forever. So what these cofunctions are is these are transformations of graphs. If I take my sine wave or my cosine wave and I transform it, I will get the sine wave and vice versa. Okay? we can use that information to find the cosine and sine equivalently here. Now, on these examples, you don't have to use the cofunction information in and of itself. If you're like, man, I really like the sum and difference, go ahead. If it doesn't look to you like these are exactly the cofunction, then just jump right into the sine and, jump right into the sum and difference. So go ahead and do A and B with the sum and difference. Out, you're going to get the cosine of pi over 2 cosine alpha minus the sine pi over 2 the sine alpha, right? So you're just expanding it out. What is the cosine of pi over 2? 0. So this entire thing goes to 0. And then, so we have minus, the sine of pi over 2 is what? 1. So this is minus 1 times the sine of alpha. So in other words, it is minus the sine of alpha. Now I'm going to use the cofunction information to do this again. So the cofunction here says I need to have the cosine of pi over 2 minus my angle. What you see is plus my angle. So if I rewrite this as the cosine of pi over 2 minus a negative alpha. Do you agree that a minus minus becomes a plus? And so using my cofunction information, this is equal to the sine of negative alpha. But negative alpha, because sine is odd, is just going to be negative sine. And that's it. You got there the same way. You absolutely got there the same way. Yes? So could you say that a little louder, because I wasn't sure what you said.
I'm confused, like, how it's supposed to work, because the cosine right there has this little parentheses area.
Here?
It's supposed to, represent the angle, it's theta. When you plug the entire expression in to a cosine.
Okay, so I think I understand what you're saying. Let me see if I can answer what I think you're asking me. We can do this entire thing like we did by expanding it out with the sum and difference, right? We have two angles, I'm adding them together so I can use the sum formula for cosine. If I knew what alpha was, like if I knew it was pi over 6, then I absolutely would just add those two numbers, those two angles, and just find the cosine of that. But I don't know what alpha is. Alpha is any angle. I know that if I add pi over 2 to it, then what I'll end up with is the negative sine of that angle. And that's because it's going back to the cofunction. So I could do it with any angle by using the sum of cosine, so the sum of angles for cosine, which is what we started out with before I erased it. I can do that for anyone because I don't know what alpha is. But if I did know what alpha was, I would just add the angles and be done with it, put in my calculator. Does that answer your question? Kind of.
So my thing that I was thinking was plugging in like the A, you see A right there?
Alpha?
No, like problem A.
Oh, okay.
So the entire area inside the parentheses, I was thinking that was the angle which you would plug into the theta, which is in the cosine.
Up here?
Yeah. I thought you would just plug that entire thing in, like cancel it out somehow.
Oh, I see. Oh, I got you. I'm tracking now. Yes. No, we don't do that because we're looking for pattern recognition.
So I'm confused what we do.
So you can do it one of two ways. So what we can't do is we can't just arbitrarily put that angle into here because it's It's going to have you're going to end up with just alpha, cosine alpha, and you can't just arbitrarily put stuff in there like that because we don't know what alpha is. So all you can do is either see if you can recognize this looks like a cofunction and write it as such, or worst case is you just use the sum of cosine, sum of angles for cosine. Does that answer your question?
Yes.
Okay. Yes, Fred.
So we did the first one and we got the negative sign of alpha.
Uh-huh.
And then, so I'm just wondering, is that how we ended up getting the negative, like how did you get the negative alpha when you did the cofunction? We have the cosine and then in parentheses pi over 2 minus negative
Okay.
alpha.
So the question is, what did I do? Well, I'm just making stuff up. No, I'm not making stuff up. When I take a look at this and I'm trying to figure out what it is that I need, if I want to use my cofunction, I need pi over 2, which I have, that's cool. But I need a minus my angle. This is not a minus my angle. But I do know that I can write a negative, a subtraction of my angle. Double negatives make it positive. So then I just rewrite this as the cosine of pi over 2, which is part of what I need for the cofunction. And then I need this to be a minus, not a plus. And the way I do that is I do that manipulation. And so now what I have is exactly this formula up above, which is what I was looking for.
Except for it comes out negative sign.
It's going to come out negative side because what happens is I'm doing the sine of that angle, and that angle happens to be a negative value. So it's a negative alpha. And so I end up with negative sine alpha because sine is odd. There's a lot going on in these. There is a lot of your algebra that you all forgot as well as the new stuff. It is a lot going on. Yes?
So when you speak about pattern, just right away,
Yes. Yes. So the question was, when I see pi over 2 or 90 degrees, if you see it in degrees, 90 degrees, plus an angle, then yes, I absolutely can say that I can write this as 90 degrees or pi over 2 minus the negative of that angle, because double negatives will make it positive. So yes, I can do that every time. It's like when we were doing proof by an induction and I said you all agree that 7 is equal to 3 plus 4. When I needed that to happen, I needed a 3 there. So I can rewrite 7 as 3 plus 4. I'm doing the same thing here. I'm just manipulating algebraically. How was that? Okay, so if you're like, man, I don't like that, cool. Just use the sum of difference. Just use the sum of difference.
So the short story of what all that means is that the cosine of pi over the angle that is pi over 2 plus some unknown angle is equal to the negative sine of that angle?
Yes. Yep, beginning and end of it. All right, for time constraints, we do need to move on. So we have the next grouping, which are the double angles. And I'm going to do a quick proof on one of these because it's pretty straightforward for especially for sine or cosine. So I'm going to actually do these proofs because they're straightforward and they're part of the identities. So you could prove them fairly straightforward. So don't write any of them down yet. Let's just go through one of them. If I have the cosine of 2 theta, do you all agree that this is a cosine of theta plus theta? Okay? If you all agree that is the cosine of theta plus theta, if I have 2 thetas, I have theta plus theta, then I can use the sum or difference. In this case, it'll be the sum of cosine. So it'll be cosine of my first angle multiplied by the cosine of my second angle minus the sine of my first angle multiplied by the sine of my second angle. Notice my angles are the same, so it's theta, theta. This becomes cosine squared theta minus the sine squared theta. There are 3 equivalent ones on this one. This is the only one that has 3 equivalent ones. I can replace cosine with 1 minus the sine squared using Pythagoras' theorem minus the sine squared theta. So this gives me 1 minus 2 sine squared theta. So here's my first one. Here's my second one. These are equivalent. If I decide that I want to take the sine squared in my first red box and replace it with 1 minus cosine, so I'm going to do cosine squared theta minus 1 minus the cosine squared theta. I'm going to get the cosine squared theta minus 1 plus the cosine squared theta. And I end up with 2 the cosine squared theta minus 1. So it's pretty straightforward. These are pretty straightforward proofs. Those are the 3 equivalent ones. So for cosine 2 theta, I can find 3 equivalent ones. I want you to do the same thing for sine now. I want you to do the sine of 2 theta. On your pieces of paper, I want you to find the sine of 2 theta. Right there in front of you on your piece of paper. Follow the same algorithm that I just did for the sine of 2 theta. So let's do the same thing for sine. So the sine of 2 theta is the sine of theta plus theta, which is equal to the sine of my first angle cosine of my second angle plus the sine of my second angle cosine of my first angle. So it's just equal to 2 sine theta cosine theta. That's it. So I'm just using the sum and difference for sine or cosine to get the other side. So I have equivalence. If I see the sine of 2 theta, I can replace the sine of 2 theta with this. And equivalently, you do the same thing for tangent. So let's take a look at tangent. So cosine has 3 equivalents, sine has 1 equivalence, and tangent has 1 equivalence. So now I can use this to manipulate my equations and my expressions by another identity. Did everyone write these down or have them find them on your formula sheet, on your unit circle formula sheet? Please make sure that you are finding all of these on that, because you get it on each test and you need to know where everything is. All right, so I look at what I have and I need to make a decision about what I'm going to do with this. Which one of these 3 would you like me to do? See? All right, so I'm looking for pattern recognition. That's why we start out with the proof by induction and all that stuff, because I'm looking for pattern recognition. I see a 2, but I don't see a plus alpha plus beta of the tangent. I don't see that in the numerator, but I do see a 2. So I think it's probably this. So I'm going to check to see if the rest of the pattern matches. So I'm looking for 2 times the tangent of the angle, and then in the denominator I'm looking for 1 minus the tangent squared of the angle. Do I have that pattern? So then this is just simply equal to the tangent 2 times that angle. 2 times that angle. So this is equal to the tangent of 24 degrees, and I walk away. And that's it. You're looking for pattern recognition. Go ahead and do A and B, please. I see the sine, 2 times the sine of the same angle. When I take the sine of it and cosine, those are the same angle. Same angle, and I see 2. Pattern recognition, what do you think this is going to be? It's going to be the sine of 2 times 13 degrees, which is the sine of 26 degrees. How is that? Cool? Let's take a look at the next one. Does it matter that I have pi over 9 minus pi over 2? No? Why does it not matter? Because they're the same thing. And I see a 2. This is the double angle for sine. So this is equal to the sine of 2 multiplied by pi over 9 minus pi over 2. This one we have to do a little bit of algebra. So this is going to be the sine of 2 pi over 9 minus pi. Still not done though. We want to be done. So I have to make this a single fraction and then deal with the fact it's going to be a negative. So I'm going to do 2 over 9 pi minus pi. Same common denominator, so I'm going to multiply this by 9 and this by 9. So I have 2 pi minus 9 pi all over 9, which gives me negative 7 pi over 9. So this is going to be the sine of negative 7 pi over 9. Is sine odd or even? Odd. So this is going to be equal to the negative sine of 7 pi over 9. How was that? Just a little bit of algebra, but not heavy algebra. All right, so now, of course, after we've got comfortable and familiar with these a little bit, we're now going to do these. Which one would you all like me to do? Good. I'm glad you asked me that one. Look at this. On this one, because I'm asked for the cosine of 2 theta, and I want it in terms of sine, I have sine. I know the cosine of 2 alpha is equal to 1 minus 2 the sine squared alpha. Do I have to change x, y, and r on this one? No. So C actually was the easiest one. So thank you for that. 1 minus 2, 8 over 17 squared. That is a terrible 8. I don't know what that was. 8 over 17 squared. So you actually gave me the easiest one to do. I didn't have to find the other angles. Like the other ones, you're going to have to find the other angles, the other x, y, r missing pieces. This one I didn't have to, so thank you. It's 8 over 17. So I have 1 minus 2 times 64. What is 17 squared, somebody? I don't know that one. 120? No, it's not 120. It's got to be 289. No, not 2 times 17 squared. What was it? 289. Okay, so now I just have to make the same common denominator. So I take this 1 over here, it's over 1, and I multiply by 289 here, 289 here. And so I have 289 minus 2 times 64, what is the 128? 128 divided by 289. And what is 128 minus, or 289 minus 128? 161 over 289. So that's my final answer. Thanks for letting me use the easy one. It's awfully kind of you.
You distributed that 2 to the 8, but not the 17?
It's because 2 is over 1, so it's going to be multiplied in the numerator only. So go ahead and do A or B. Which one do you all want to do, A or B?
We'll do B.
You'll do B. Thank you for choosing B. So go ahead and do B. Hopefully that it'll be fixed by the time you do the test. I know that the tangent, my formula is the tangent of 2 times my angle is 2 the tangent of my angle, and then 1 minus the tangent squared of my angle. Now, when I'm chasing the 3, 4, 5 pieces, that is the replacement for the tangent or the cosine or the sine of the angle. So once I find that ratio, I replace that trig function with that ratio. That ratio does not replace the angle, it replaces the function part. So you're going to see a lot of my stuff is 3, 4, 5. I have the sine of alpha is negative 4 over 5. This is a 3, 4, 5 triangle. So quadrant 3 is where I am. So I have y is equal to negative 4, r is equal to 5, and x, because we are in quadrant number 3, this is a negative 3. So it's a 3, 4, 5. I use these a lot, as well as the 5, 12, 13 triangles. So that tells me my tangent in that tangent of alpha, in that quadrant, is going to be a negative 4 over negative 3, in other words, 4/3. Yes? Aren't we in 3? We are, right? Because I am sketchy. You never know what I'm doing. But we are in 3. Okay, so now I'm going to come back here, and wherever I see the tangent of that angle, I replace it with that ratio. That ratio does not go into the angle position. It is the ratio replaces that entire thing. So this is going to be equal to 2 multiplied by 4 over 3, 1 minus 4 over 3, the quantity squared. So I end up with 8 over 3 in the numerator. In the denominator, I'm going to get 1 minus 16 over 9. What is my lowest common denominator? 9. So this one, I'm going to multiply everything by 9. Multiply this by 9, multiply this by 9, multiply this by 9. In my numerator, this 3 and this 9 will cancel into a 3. So 3 times 8, which is 24. In my denominator, I'm going to have 9 minus 16. So I'm going to have 24 over 7. And that's my final answer. How was that? Is that okay? Delicious. It was delicious. Scrumptious even. All right. Hey, look, and the fun never ends. Half-angle identities. Half-angle identities. You will either love these or hate these. It depends on how you look at them. The reason I say you'll either love these or hate these is because if you don't want to find two angles that add up to or have a difference of 15 degrees or pi over 12, you can use these instead. So you just have to remember where you're standing. Now the plus and minus here is determinant on where you land when you get done. So plus and minus depends on the quadrant in which the terminal side of pi over 2 is. So if the terminal side of pi over 2 is in quadrant number 2, and you're trying to find the cosine of that, then you're going to take the negative part of it. So it just depends on where you are as to what you choose. So like I said, we don't have to take the sine of 15 degrees as the sine of 45 minus 30 if I don't want to. I can rewrite it with the fact that I know that 15 is equal to 30 divided by 2. Do y'all agree that 15 is 30 divided by 2? So I can rewrite this as the sine of 30 divided by 2. So if that's 30 divided by 2, I can go back up to this one right here. 30 divided by 2 is still in quadrant 1. 15 degrees is still in quadrant 1. And so I can use this formula, and it's going to equal the positive square root of 1 minus the cosine of 30 degrees all over 2. So this is going to equal the square root of 1 minus the square root of 3 over 2 divided by 2. I can't have a fraction within a fraction, so I'm going to multiply everything by 2. Multiply this by 2, this by 2, this by 2. And so I get the square root of 2 minus the square root of 3 over 4. Square root of 2 minus the square root of 3 all over 2 is my final answer. And I'm going to leave it like that. I'm going to leave it just like that. And it'll be the best we've ever had leaving it like that. CJ.
You said the plus or minus is going to affect it where?
So you know, so this angle, basically, the gist of it is, where is this angle to begin with? Which quadrant am I in?
First.
So I know when I take the sine of it, it will be a positive answer, so I take a positive of it. 7 pi over 8, where does that one land? Two? Quadrant 2? So when I do my half angle, I know I'm going to take the negative of it because that's where 7 pi over 8 is. So I'm going to take the negative of that. Yep. So go ahead and do A, B, and C. I'd like you to try doing the double angle or the half angle, but if it's like, no, I don't like it, go ahead and use the sum and difference. Can't yet. As a hint, 75 is equal to 150 divided by 2. How do you think I'm going to do the 7 pi over 8? How am I doing, first of all, how am I doing the going from 75 to 150 divided by 2? What am I doing to the 75? What am I doing to the 75? I'm multiplying the numerator by 2, right? So if I have 7 pi over 8, what do you think this is going to be equal to? No, well, it's going to be 14 over 8 divided by 2. But I'm not going to write it as 14 over 8 divided by 2. What am I going to write it as instead? I'm going to write this as 7 pi over 4 divided by 2. 7 pi over 4 divided by 2. Now, I know that this cosine is going to be a negative number, so I need to take the negative of that square root. I go back up to my formula, and cosine is going to be 1 plus the cosine. So it's going to be 1 plus the cosine of 7 pi over 4 divided by 2. I'm using the negative again. Right here, I'm using the negative because 7 pi over 8 is in the second quadrant, so my answer needs to be negative. So then this is going to equal to the negative 1 minus, or plus, 7 pi over 4, where do I land? Which quadrant is 7 pi over 4 in?
4.
Quadrant 4. So what is 7 pi over 4, cosine of 7 pi over 4?
Square root of 2.
So it is going to be the square root of 2 over 2 divided by 2. Same common denominator is 2, so I multiply everything by 2. My final answer is going to be the square root of 2 plus the square root of 2 all over 2. I just kind of skipped some steps because I need to finish the last one. Finishing up this last one, I'm going to do the tangent. This is going to be equal to the tangent of 150 divided by 2. Now, if you all don't like the half angles, you don't ever have to use the half angles. You can use the sum and difference. It's okay if you don't like these. You can use the sum and difference. And so this is going to be equal to 2 times the tangent of 150 degrees, 1 minus the tangent squared of 150 degrees. Oh, no, sorry. That is the wrong one. This is going to equal, and come up here, it is cosine sine, or cosine cosine, 75 degrees. Where does 75 degrees land? Which quadrant? Quadrant 1. So I'm going to take the positive of it, and then it's going to be 1, and it's plus, a minus in the numerator, 1 minus the cosine of 150 degrees, 1 plus the cosine of 150 degrees. The cosine of 150 degrees is what? It's the
Negative square root of 2.
square root of 3 over 2.
Negative square root.
And then 1 plus the negative square root of 3 over 2. What is my common denominator? So multiply everything by 2. So this is going to equal the square root of 2, and this will be minus minus is a plus, the square root of 3, and then it's going to be 2 minus the square root of 3. And I'm just going to leave it like that. Have a great day. We'll pick up more of these on Monday.
I should get that